So in this video tutorial I am going to teach you how to write a program in 8086 assembly language program in 8086 to take the character input from the keyboard and display the same character in the screen, output screen, using emulator 8086 EMU 8086, which is the emulator where I'll write the program and execute it to show the output. So first of all, after opening this emulator 8086 application, I'll select the new application, new program to write, and we should select the empty workspace, and then I'll be writing the program here. So before writing the program, mostly in assembly language program we use semicolon to write the comment, and here I'm going to write a program, and the program title is to take assembly language program ALP in 8086 that accepts the character from keyboard and display it on the output screen. So I'll be writing this program today here. So for writing this program, first of all we should define different types of assembly directives. About the assembly directives I have already described in the previous video tutorial, and then here I'll directly write the program. First of all, we'll write different types of assembly directives like dot model. This compulsory assembly directive, it is the compulsory assembly directive dot model assembly directive dot model and small dot model small. It this dot model small, this line directs the assembler to occupy the for code segment less than or equal to 64 kilobyte, and for data segment also less than or equal to 64 kilobyte among 1 MB of memory that is supported by 8086. Dot model is small. Now dot stack 100 as this dot stack 100 as this line directs the assembler to occupy to separate 100 bytes separates 100 bytes of memory for stack segment. And now these two lines, now I'll be writing these two lines directs the assembler that how much memory to be made available to make available for stack segment, code segment, and data segment. And now the next assembly directive I'll be writing is the data directive dot data directive, and the data directive is used to initialize the data segment. Normally it is used to initialize the data segment to define different data variables. It's in this program I'm giving the data using the keyboard, and thus I'll not define any data, for the program. So and the next assembler directive I will be writing for defining actual part of the program is the dot code directive. This directive defines the actual assembly language program to be executed. And in dot code directive we should write the different types of procedures in dot code directive. So I'll be writing we should use the proc directive to write the different types of procedure, to define different types of procedure, and we should keep the name of the procedure, a certain name of the procedure in the unique name of the procedure, and here I'll be giving the main is the procedure name. And so I have started the main procedure, main proc, writing the main proc, and then now I'll write the next start of directive that directs starts the actual starts assembly language program, that starts the assembly language program. Below this directive there are the actual program code that should be written, and here to the first part of the program is to accept the character from the keyboard, that is the read the character input from the keyboard, For that in 8086 we should write move AH comma 0101H and int 21H. These two line of code accept the character from the keyboard, and they store the input character in the AL register. Accepts the character from keyboard and store accepts the character from keyboard with echo. It displays what character has been entered. So it accepts the character from the keyboard and also echoes that character, and it stores that character on AL register. It is one of the 8-bit register used in 8086 microprocessor. So this is another line. This is int refers to the interrupt instructions used in 8086, and int 21H is one of the function, interrupt function, that is used for handling the different types of keyboard functions. And int 21H always while executing it sees what is stored in AS register. There may be different values in AS register from 00 to FFH, and 01H does accepts the character from the keyboard. Similarly, if there is 02H in AS, it displays the character stored in dual register on the output screen, and similarly if there is 09H, then it is used to display the string stored string that is defined by DX register. So we should before writing any program in 8086 we should know about these functions which is used by DOS bias interrupts to execute different 8086 programs. And now this two lines of codes act as a function like kitcat in 80 in C or C++. So we accept one part of the program has been completed. Now the next part of the program is the display the same character on the output screen. Now to display the same character on the output screen, we have the similarly the next function move AH comma 0 to H int 21H. So these two line of code display the character stored in DL register on screen. So these two lines of code. So here I have shown that the character to be displayed should be stored in DL register, and the character input is stored in AL register. So I should to display the same character that has been input from the keyboard, I should copy that character from AL register to DL register AL. So and this copies the content of AL register to DL register to send on output screen. In this way we can write the main part of the program. Only these 5 lines which I am writing here are actual the main part of the program, which are converted into 8086 assembly language program, which are converted into binary form. But all other this line of code which I am writing are only assembler directive. They only direct the assembler while executing to denote how much memory is occupied and which is data and which part of the program stores code and what is the name of the procedure. In this way these are denoted by these assembler directives. And I have started startup directive I have written. So I should in that assembly language, in the assembly language program, actual assembly language program, by using .exit directive ins ALP, and then now I should in the procedure which I had started also, int p directive is used to end the procedure, and before writing the int p directive I should write the same name of the procedure which I have started while I have written while writing the while starting to write the procedure. So here should be main np because this main np procedure should be started, which I have started should be terminated. This terminates the procedure. This main np terminates the procedure main. So these two line of code are also assembler directives. And now to terminate the overall program, overall code segment I should write the end directive, and one of the procedure which this may be there may be number of procedure like executing the program. Here I have written main procedure, and there may be other add procedure, sub procedure, subtract. In this way I may write a number of procedure within code segment, code within the code. So to end overall program, overall main program, I should write the end directive, and one of the procedure names should be written here. So I'll be writing main. In main is I have this main only as a procedure. In this way this is the overall program. terminates the overall program. So this is in main is used to terminate the overall part of the overall program. So this is how we can write the program in 8086, assembly language program in 8086 that accepts the character from keyboard and display it on the output screen for the DOS bias mode, and this will be executed using DOS bias mode of 8086, which we'll see here. Now to execute this program or to emulate this program using EMU 8086, I'll select this emulate, and then now if there is an error, then there will see an error, but here I have written the program correctly, so I didn't see any error. Now we can see different values of registers like AX, BX, CX, TX, and which value is stored temporarily on which register while executing this program, clearly in this EMU 8086. And here also we can see the different values of flags while executing the what are changed while executing the program. And now to run the program, now I should again select this run program, and then now on the output screen I'm asked for entering any keyboard input which is done by this part of the program, this move AH, 01H, in 21H. These two lines of code are executing now, and they are asking me to give some input, character input. So if I press here A, then eventually this part of the program has been executed. These remaining parts of the program have been executed, and I can see here the character which I have input A has been seen here, because this 01H function accepts and as well as echoes the same character which has been given by the user, which has been input by the user. And now the next character is the output of the program, which has been given by move AH, 02H, in 21H, these functions. So in this way I have written the program in 8086 to take the character input from the keyboard and display it on the output screen. Here I can also see the message that program has written control to the operating system. This means that this is the program in 8086 executed using DOS bias mode. That is the operating system. These DOS bias are used by the operating system or smash mode by operating system. So in this way we have executed 8086 program using DOS bias mode, and the program the program accepts the character from the keyboard and display it on the screen. In this way I have executed this simple program which can be the base for writing other programs in 8086. These parts normally, this part and these lines of codes normally remain same while writing different programs, but only the part of program that will change is only these 5 lines of codes Here we can add number of lines of codes, and only the change will occur in this place between .startup and .exit directives. In this way, you can write a program in 8086 that access the character input from the keyboard and display it on the screen. So that's it for this tutorial.